really comes is, when you see this, and most Catholics, when they see this, then they say, huh? Why does the Vatican have an observatory? Why is it wasting its time with this? What is this all about? So, let me just point out to you from the very beginning, really, the church has always been interested in science. Has always been interested. So right from the 16th century, the church has been interested in science. And if you would look along the course of this history, I can name you at least 200 scientists who were priests and belonged to the Catholic Church and made great contributions. But I'm going to just give you a flavor of it. This named 4 people to give you a flavor of what they did and how much of an impact they had. The first one here is Christopher Clavius. Christopher Clavius is responsible for reforming the calendar of the church. He reformulated the Gregorian calendar, which we follow today, from the previous one which we had, which was the Julian calendar. There was something wrong with the Julian calendar. They couldn't get the dates of Easter right. The equinox was not coming on the same day every year. So the Pope turned to his most trusted mathematician, who was a Jesuit at that time, Christopher Clavius, and he asked him, go and figure it out. Use your maths and figure out how we can fix this problem once and for all, so that the missionaries in India and the missionaries in South America can figure out exactly for the next 1,000 years when you have to celebrate Easter. Remember, those days you couldn't phone them up and say, Easter this year is on the 24th of April. You couldn't do that. You had to figure this out. So if you look at his books, and I'm pointing it out here, I hope you can see the fine print. 2008, 2009, 2000, he's got it all figured out for the next 500 years. So this is Christopher Clavius. By the way, he wrote the recommendation letters for Galileo Galilei. The second person I like to talk about is a person by the name of Father Francisco Grimaldi. He is not very well known among the scientific community, but he is important, and the reason why he is important is because he made the first map of the moon. And because he made the first map of the moon, he got the opportunity to name the craters according to the people he liked. So that's why you have a whole bunch of craters named after Jesuits and popes, 32 of them. And the reason why they did it is not because these Jesuits were so great, but just because the guy who did it first, Francisco Grimaldi, was the first to do it and put his friends on the moon. So, the third person I like to talk about is a little bit more closer to home. His name is Father Agnello Secchi. In fact, we are celebrating this year an anniversary, 100 years since his birth. This man is also very less appreciated in certain aspects of astronomy. He's actually less appreciated in the United States, but much more appreciated in Europe. And the great thing which he did was he made a big innovation in astronomy for its time. Before his time, people were always looking at the stars and trying to wonder how they move. How do they move? This guy turned to the stars and started saying, what's the physics behind it? What makes the stars shine? What is really, what elements are they composed of? So what he did was, he took a telescope and he fit a spectrograph, that means a prism, at the end of the telescope. And when you split the light from the sun, it turns into a little rainbow of many colors. And he actually studied the lines of these things, and he realized that all these stars were similar and different in a little way. And he kind of understood, how do you classify stars? How do stars grow? And finally, what are they made of? So he's actually the first guy who proved that the sun and the stars are the same thing because they have the same elements. This is a great thing. And the last person I want to bring about, this is the fourth character who's much more recent to home. This guy is not a Jesuit. He's a Belgian priest. He is Father Georges Lemaitre. Now, Father Georges Lemaitre was a brilliant physicist. When Einstein, who had seen this picture over here, published his equations of general relativity, he's most famous for this, Lemaitre took them and tried to solve them and apply them to the cosmos. And he immediately realized that if you apply it to the cosmos, that the heavens then are expanding. If you apply his equations to the cosmos, they are expanding. And therefore he said, if everything is expanding, then it must have come from a single point. So this man is the father of the Big Bang. If the Big Bang, and many Catholics are like, Big Bang, is that Catholic? Big Bang is a very Catholic idea. It's a very Catholic. A Belgian priest was the founder of it. Today, the International Astronomical Union passed a resolution, just today, and there is a famous law which is known as the Hubble law, named after Edwin Hubble, which talks about the expansion of the universe. Today they renamed it as the Hubble-Lemaitre law, because Lemaitre discovered it first in Europe, but because it was written in French, nobody spoke French here, everyone spoke English, and then of course nobody recognized that they both discovered it around the same time. George Lemaitre, a few years later, finally given his due. This gives you a flavor of 4 characters in the history of the church who made tremendous contribution. The Vatican Observatory continues in this tradition. But the Vatican Observatory was founded somewhere around 1891. And it's called Vatican Observatory because it was founded after the Vatican was founded. So the Vatican was founded in the 19th century when the Pope lost his land to Italy. Then he was locked up in that small little part in the center of Rome. That became the Vatican. And when he was locked up in that land, he wanted to prove that he was a country. Because he lost all his land, but he wanted to prove that he was a country. Every country in the world had a national observatory. The only way to show that he had a country was he founded it, an observatory, to show that he too was a country and was the ruler of a country. That's the political reason. The better reason, which you should remember, is this. This is what he wrote when he founded it. That everyone might see clearly that the church and her pastors are not opposed to true and solid science, but that they embrace it, encourage it, and promote it. How many Catholics in the world would believe a statement like this? That the church and her pastors are not opposed to true and solid science. So the task of the Vatican Observatory then is not to defend the Pope against other people who try and attack him, but is to do true and solid science. So the people who are there's a bunch of us, 14 or 15 of us, this was at our last meeting. Some of you may recognize Brother Guy Consolmagno here. He's a Detroit native. He is now the director of the Vatican Observatory. I'm up there in the corner, somewhere there, among the more younger folk of the observatory. This was at our last meeting in 2016. We do a variety of research. So all of us are in various different things. And our primary purpose is to do good science and to interact and influence different types of people. So we have 2 purposes, basically. One is to show the church itself that science and religion go hand in hand. And that the only thing we can do this, is by coming to parishes and giving talks and showing people that science and religion go hand in hand. But we have another mission, which is to go and reach out to the astronomy community, the scientific community, and talk to them. And these are audiences which the church would never normally reach, because they don't come to church. And you can only talk to them if you have some sort of authority. And you only have authority if you do good and solid science. So this is the purpose of the Vatican Observatory. Do good solid science, talk to the astronomers, influence them, and spread the message to the faithful that science and religion go hand in hand. So we do a large variety of sciences. This is our advanced telescope in Tucson. It's a 1.8 meter telescope, and we observe the skies with it. We observe galaxies and stars. But there's also a great amount of work within the Vatican Observatory on meteorites. We host the third largest meteorite collection in the world, thanks to a variety of donors. We have at least 10,000 samples of meteorites are things which fall from the sky. And this is a showcase display of it. And recently, the Vatican, with the observatory, hosted a small conference which made some sort of headlines. It was the curation of extraterrestrial objects, which means objects which fell from the sky. Of course, the media thought it was something really fascinating, that you really had spaceships coming in and giving us stuff, and we were actually curating that. These are just meteorites coming in from the skies. So if this is true and all that I told you is true, then what about the stories we hear in the media? What about the normal kind of thing which we normally hear about? Hey, the church is always against the science. Think of Galileo and his time in the church and how the church persecuted him. And since then, the church has always been against science. This is the narrative which we normally operate under. Now, the story of Galileo and the church is very complicated. It is a really complicated issue. What exactly happened at that time? And there's a lot of historical study being done at this moment about exactly why did the church and Galileo fight. And we can rightly say also that the church made a huge mistake for which it apologized in 1998 through John Paul II. But there are a lot of bits and pieces of this story which are not really very clear. I'm not claiming to be an expert on this, but some things I can tell you which are true. Galileo was living in a time when he made these major discoveries, and then he began to say, this goes against the Bible. Therefore, you have to reinterpret the Bible. So he went up to the bishops and the priests and the Pope even and said, hey, you have to reinterpret the Bible. The popes were not interested in reinterpreting the Bible at that stage, partly because that was the time of the Reformation. They were already battling the Lutherans in the north and the Calvinists from in Switzerland who were talking about reinterpretation of the Bible. The word reinterpretation was a bad word in those days. And therefore, naturally, he was frowned upon. And what's most interesting about the story is that the Pope at that time, Maffeo Barberini, was for 20 long years Galileo's biggest supporter and patron in Florence. He was from Florence, Maffeo Barberini. He was his biggest patron. He gave him all the money to do the research which he did. And then when he became Pope and when Galileo published his books and would not listen, Maffeo Barberini condemned Galileo Galilei. It's quite surprising. Actually, Galileo Galilei did not have too many friends. He was quite a vocal person in what he wanted, and kind of, he knew hubris was a bit in the air at that time. He also fought with many Jesuits, partly not because of whether it was the earth was going around the sun or the sun going around the earth. He fought with the Jesuits about who discovered the spots on the sun first, because the Jesuits claimed they discovered it first. He claimed they discovered it first. It's a big, complicated mess. What I find interesting in the story is that Galileo was put under house arrest. He was not maltreated, sent back to Florence, and then he wrote many of his greatest works after he was arrested. And the popes allowed it. In fact, two of his daughters, his only two daughters, became nuns and long supported him till his death. And he remained a Catholic till his very end. The conflict between religion and science was not taking place at the time of Galileo Galilei. In fact, nobody talked about Galileo Galilei for the next 200 years. It was only in the 19th century when there was strong opposition against the church, again being anti-clerical, anti-church in France and Italy, that they went back, picked the story of Galileo Galilei, and made it as a poster example of how the church is against science. That is the narrative you will hear and continue to hear. In fact, there are actually much more tragic stories where the church actually punished people and burned them, really burned them, because they were heretics. And nobody uses those stories, but anyway, they picked up on Galileo Galilei because Galileo Galilei is actually one of the most brilliant people of his time. I like to put it this way. The story you hear about Galileo Galilei is a take on it by modern, from the 19th century understanding. In a certain sense, it is the myth we live under. And the myth being a positive, it's a paradigm we live under. It shouldn't be the dominant paradigm. It shouldn't be the way we think. So rather, I'm going to take this approach and say, hey, we have another paradigm. Okay. Please remember, the Pope always wanted to hit Galileo Galilei on his head with a telescope, which he tried to show him. But I want to take another paradigm, which is a much older story than what we know. And we all know this story. It's the story of the three magi, the three wise men. We all know this story from the Gospel of Matthew. We have these three wanderers setting out from their distant lands and coming, observing a star, not knowing what they would find. They are wise men, they may be kings, we don't actually know. But they were wise, they were searchers, seekers after a truth. And they went in search of this truth. And then eventually they found a child, they found Jesus, and they bowed down and worshipped him. I'd like to use this paradigm and try and explain how science works. And let's see whether it works or it does not work. This is the new innovative part of what I want to try and show today. Is what is the difference between these three wise men and us? So the first thing which I'd like to say is that these three wise men were searching for something which was, in a sense, much greater than what they were. They were looking for something which was new, they were searching for something. It's very difficult to say they were searching for the child Jesus. It was very difficult to say they were searching for God. We know they looked at the star, that's what Matthew tells us, and they've set out on the search. In fact, if you would think of it, it's like someone saying, I have a deep desire within me. I have something deep within me. I have this desire within me. And I want to set out on this quest. These three wise men, these travelers, would be examples of people who search out on a quest. So in a sense, just like the three of them, we too are, in a sense, searching for some quest. We are fellow wanderers, fellow travelers, fellow magi. In a sense, these magi tend to be our predecessors. I'd like to point out that in a certain sense, what these guys were doing was, at that time, was perhaps not the rest of the population would be doing. I mean, most of the other people at that time would quietly sit down in their houses and not bother to set out. It's too risky, it's too difficult, it's not worth it. These three men set out. I think this setting out epitomizes everything that is noble in the human quest which we have. Whether it be in arts, in poetry, or in the sciences. We try and search for something which is greater than ourselves. I'd like to point out that these three, for me, in a very poetic sense, were the first scientists, as it were. Let me try and then weave a tale around these three men. So the first thing which we can ask ourselves is, so the first thing which I'd like to point out is this. What is really what they're looking for? So you will all know that if you would look up at the night sky in the night, and look up in the heavens, and you see the stars, and some of you were just telling me beforehand, it's a supernatural experience in a way. You see the heavens and you say, wow. Now you take the same experience, okay, and you take a professor from the University of Michigan, these high-ranking schools, or you take a kid from the Sahara Desert, or you take even somebody from South America or from India. All of them, when they look up in the heavens, all of them will have the same experience. Go, wow. It takes their breath away. What is it that takes their breath away when they look up at the heavens? What is it that is so common in all of our human experiences that all of us, when they look up, go, wow. Has this been our experience? I mean, can we identify with this? Yeah. So what is it? And I want to examine this. So my point is that these three men probably had that experience. What is that experience? So I need to point out that, hey, you look at the night sky. Now these are not what you're going to see in the night sky, because this you need a very good, powerful, expensive telescope in space to see this. When you look at it and your breath goes away. What? Wow. What does it mean? My way of looking at it, and then bear with me for a moment, is that when we look at the night sky, what is actually happening to us is that there is an inward quest in each of us for something which is beyond us. There's an inward quest for something beyond. We call this in philosophy the transcendental quest, to look beyond us. We are constantly searching for the beyond. And when we look at the night sky, we see this most transcendental. Do you know the meaning of the word transcendental? Transcendental means something which is beyond us. There's this quest to go beyond. So you look at the night sky, you see this transcendental quest, and you say, wow, this is really out of this world. It's transcendental. Michelangelo tried to epitomize this in a painting. This is on the Sistine Chapel. And it epitomizes man reaching out to something which is infinite. What Michelangelo paints on the other side is God the Father. But what is on this side is this inner quest which he put into a painting, inner quest within a person to reach for something which is beyond. This is what I call as the transcendental dimension in all of us, each one of us sitting here. Some of us follow it, this inner quest. Some of us have the courage to go beyond ourselves and to answer that quest. And as I said, it could be in various fields which you may be doing. Arts, poetry, in your business, in whatever you do, you try to be the best of what you want to be. That is the transcendental dimension of being a person. And this is what Michelangelo quests for. Now what Michelangelo realized, and what philosophers realize, is that the most transcendental thing you can ever reach for is something which is most beyond us. And that is the divine. The most transcendental thing you can ever reach for is the divine. And everything else then becomes like a mere stepping stone towards the divine. The way I like to think of it is, everything we do in our professional lives, whether it be computer science, whether it be medicine, being a doctor, a researcher, an environmental activist, a political activist, these are all expressions of this thing which goes to the divine. And the better we do it, the more we are saying yes to this transcendental urge within us. By the way, the person who puts it within us is the same person to which we go towards. Now, if this is how it is, then the sciences is also an expression of this transcendental search. And then the reason why you go wow when you see the thing in the sky is because the heavens is the most transcendental thing of all the sciences. I mean, if I would publish something in medicine, not many people would read it in the newspaper, but if I publish some small thing about this, about the heavens, it immediately gets great press coverage. Because the astronomy, the heavens, is the most transcendental thing of all the sciences. The church always recognized it. The church called astronomy the queen of the sciences. I mean, it's always been called the queen of the sciences right from the 16th century. Partly because, A, it is the most transcendental thing you can be. Does this make sense? Mm-hmm. Yes? Okay, fine. So if this is true, then let me return back to the story of the three wise men and ask the question, what can we learn from this? Dig into this story a bit more. What did they why did they set out in their search? What did they search for? And what did they expect to find? Lovely. So the question is, why did they set out in search? So I gave a hint to this question in the beginning of my, in this a little while back. I kind of said they kind of set out an answer. They kind of set out to an answer to themselves. Right? There was this quest within them, there was this urging within them, and they answered that quest. But let's dig a bit more deeper into our experience. I like to put it this way. All of us, in some way, are living in a sort of thing which comes from the first book of Genesis, which is we are living in exile. Okay? Now, what do I mean by this living in exile? What I mean to this is that all of us may have, we may experience love, we may experience community, we may experience companionship, we have some knowledge, but we never experience the full warmth of community. We never experience the full warmth of relationships. We never experience the full warmth of knowledge. And there's always this urge for completeness and something more. This is our human experience. We all have great lives, but right now, in a sense, we also suffer in our lives, in whatever way we have. This is our exile. Now the reason why everyone goes wow when they see their heavens is that because when they look at it, even for a brief moment, however brief that moment may be, they are temporarily put out of exile. It is like you forget about your day-to-day, day-to-day worries. How am I going to pay my bills? What about health insurance? And what am I going to eat for lunch or for dinner? And then you remember, you forget about that, and you're so caught up in the moment. My boss, which is Brother Guy Consolmagno, always used to tell us, and we used to have lunch, he used to say, I do astronomy because it reminds me that there's something more than what I had for lunch. It is true. It temporarily puts us out of exile. So in a sense, they set out on their search not only to answer their question, but they wanted to seek something more, to temporarily get that thing out from their systems. So in a sense, it was out. I think all forms of people who go to some form of extremes are people like this. People who go to the best of their careers. And in a sense, like the three magi, scientists, engineers, all do this. They set out on this search. The question comes, what did they search for? This is a bit more difficult question to ask. I believe that the wise way to think of this is they were searching for something which is called as meaning. Meaning in life. What do I mean by this? As human beings, all of us need meaning. We need meaning to go forward in life. Now, when you talk about meaning, in philosophy, we always say that if you have a system, a box, you cannot find meaning within the system. You always have to find meaning outside the system. So if you I like to think of it, you start playing a game, any of these board games, you have a set of rules, but actually, why do you play the game? You play the game because you all has instituted a price, which comes from outside. So there's a meaning, there's a system which is outside. Similarly, for our daily lives, meaning always comes from outside the system. So the great Rabbi Sachs, who I had to borrow this idea from, he would say, science tells you how the universe works. Science tells you how the universe works. It can't give you meaning. Meaning must come from outside the system. But science tells you how the system works. Meaning must come from outside the system. Now the thing which is most outside the system, as we talked about this transcendental dimension, is the divine. Therefore the only thing which can give you meaning in life, hey, is not science, but religion. So it's a nice way to think about science and religion. Science talks about how things work, how do things operate, why are things the way they are. But if you really want to go on in life, that comes from outside. I like to re-emphasize that meaning is really the essence of all dimensions of our human life. And you understand this best when there is absolute loss of meaning. When there's absolute loss of meaning, there is a loss of hope. It leads to people committing suicide or death. They have no urgency to go forward on in life. This would be a very strange way to talk about religion and science in terms of hope, in terms of meaning. But in a sense, this is true. Science cannot give you meaning. Only religion can give you meaning, something which is divine. Now, I've placed it in a very interesting context. And this gives you another dimension which I will not talk about. But if science tells you how things work, how things are, and religion gives you meaning, what about ethics and morals? In itself, science cannot talk about ethics and morals because it tells you how the system works. Ethics and morals comes from certain meanings and values which come from outside the system. So when scientists talk about the most ethical thing to do, they have to borrow something from outside, some philosophical construct, some ideological construct from outside. Science is not equipped to talk about ethics. I'm not going to talk much about ethics because, thank God, in my field, there's not much of ethics. There's not much of ethics when you look up at the heavens and nobody's going to say, you shouldn't be doing this and you shouldn't be doing that. Okay, let's move on. And then let's go on to the more difficult question. What did they expect to find? What did the Magi expect to find at the end of the journey? I think this is a very tricky question. Did they expect to find a child? No, they were not looking for a child. They were following the star and they were going to see what's coming out next. That's all. So, in a sense, by setting out on this journey, they needed certain things to motivate them and to go forward. Because every step of the way they were filled with doubt. Am I going to find what I'm going to find? Am I going to find what I'm setting out to find? So I like to point out that even sometimes in my own research, I find that when I start off on a project, I really don't know what's going to come out at the end of it. I really don't know what I'm going to. And so quite often, many times I start off a project and it's a dead end. I tried it, it didn't work. Close the project, move on to the next one. But I kind of pursue it to the end because I somehow have faith. I somehow have a hope that it will come to some sort of fruition. Now I'm going to make my most controversial statement of the evening. I think if you want to do good science, you need faith, hope, and love. If you want to do good science, you need faith, hope, and love. Let me explain this briefly for a moment. So bear with me. Let me start off with faith. Why do you need faith? First of all, you need faith, because you have a faith that my project will come to something. That's how I set out. If I'm not good, it's not going to come, I won't start on the project. But let's take a little more deeper element to this. Do you realize that science has occurred or began to start about in a culture which is the Hebrew-Greek culture of Christianity? Okay? Science happened in the Hebrew-Greek culture of Christianity. It didn't happen in the high civilizations of Egypt. It didn't happen in the high civilizations of China. It did not happen in the high civilizations even in South America. It happened in this confluence of this Jewish and Greek world, which happened to confluence in Christianity. One of the great contributions of the Hebrew world was their belief that God was a good God and that He created the world in a certain order. In contrast to other cultures which suggested that God was capricious. God could do whatever He wanted. God was had His own whims and fancies. In fact, in the Greek world, gods fought with each other, and depending on how they fought with each other, things happened here. Now, you say, wait a second, but this is a very fundamental assumption. I would only do science if I know that I assume that the world is going to stay steady, and it's not going to change, that there are rules and there are laws and that I can study them. If my assumption is that the world is capricious, just as my God is capricious, what's the point in trying to discover a law? Because tomorrow it will change. Science could only take place in a culture which understood and assumed that God was good and He created the world good. Combine that with Greek rational thought, because that's what the Greeks gave us. And together in the Christian understanding, a good, stable God who created the world good, and the using of our intellect comes together to create a good atmosphere for science to flourish. Now you will tell me, but what about the pyramids? And what about these great Inca monuments? I'd like to point out that science is different from technology. Technology is about how do you do stuff. Science asks the question, how does it happen? What is the rules behind it? How does it operate? Science and technology are very different. Technology often predates science. Technology often predates science. Science is really asking, oh, wow, how does that happen? The best illustration I have of this is from the Inca civilization. Now, the Incas looked up in the night sky and they saw the planets. And for them, they saw the planets and they noted the positions of the planets. So they could see how it was moving in the night sky, and then they could do some extrapolation, drawing lines on curves, and they could predict when eclipses happened. They could predict when you had certain conjunctions between two different planets. They could predict with remarkable accuracy. Did they do science? Well, not really. They had technology. They never really asked the question, what's actually happening up there? Why can I do this? For them, it was like light bulbs on the ceiling just moving. That's technology. They could predict how the light bulbs move. That's technology. But when you go like Galileo and look up and say, wow, how does that happen? Why does the planets move around the sun? What is that which keeps things together? Like Newton asked, and drops an apple. He never dropped an apple. But asked, what is that thing which holds the planets around the sun? What type of force is that? That is science. Science is that which asks the questions. Is this clear between science and technology? So technology often predates science. Good science accelerates technology. That's the marvels of the 21st century. But technology and science are very different. Now I went on this kind of thing trying to show you the requirement of faith in all of this. Even in the science we do every day, I often make a number of assumptions. I ask the questions, what new thing can I learn today which has not been already known? And I kind of assume that the guys before me actually did a good job of finding out those things, that Galileo was right, that Einstein was right. I have full faith in them. I actually don't go and check what they did was right or wrong. There is a certain dimension of faith also in the sciences. Let me move on to hope. This will be easy to understand. Hope is essential to the sciences. Every time I write a grant application to the NSF, the National Science Foundation, or every time I write a grant to my university, or even ask my bosses at the Vatican, please give me money for a new instrument, I am filled with hope that the experiment will work out right. Because the next time I ask for money, I won't get it. Hope is essential to the sciences. We hope that our work will progress. We hope that our knowledge will increase by leaps and bounds. Without hope, you can't do any science. Hope is there in science. So faith and hope are really easy to understand. The more difficult question is love. How do you talk about love in science? This is a real, I'm going to take you on a wild goose chase, and I'm really stretching it further. So increasingly today, people are becoming aware that science is not just reporting the facts. Okay, I don't say, oh, the earth is round, the earth moves around the sun, it moves at this and so speed. Science is not reporting the facts. Science is actually a conversation about the facts. In science, what we do is that you can't have science without a community. So I can't sit isolated in my cell in some palace of the Pope in Rome and do good science. I have to have a conversation with other people about it. So I publish something in science, they read it, they publish back, they kind of back and forth, and together we come to a conversation about the facts and about reality. So the best way to talk about is, just like religion is a conversation about the universe, but from a particular dimension, science is also a conversation about the facts, about reality, about our universe, from a very particular dimension. It involves, my main point is, it involves community. You can't sit up isolated in your room and do science. And that's why it's so nice to come to the University of Michigan from the Vatican Observatory, because I have a flourishing community who can critique my ideas, we can go back and forth, we can sit down there, go down rabbit holes because not a good thing, and come out again and then try and come to some understanding. And it's all about this interaction. Good interaction gives you good science. The best places of universities in the US are places where you have good communities flourishing, where you get the great minds together and you produce great science. Now, we are becoming increasingly aware in the sciences, especially in the last few years, that the better science is done when you have a large number of voices being heard. When you have a few people with the same ideas, you're not going to have good science because they don't critique each other. The professor who I work with, his name is Eric Bell, he and I understand each other very well. And sometimes two of us, we don't critique each other because we understand, we are so comfortable with each other, we think we understood everything, we publish it, and then somebody will write a critique to us and say, hey, you guys are all wrong. Because we are so common that, we love working with each other, but we don't hear the diversity of voices. And you must have contrary opinions, contradict and say, hey, this is not right and that's not right, you have to prove it, I have to convince the community. So in the sciences today, we are increasingly being aware that you need a community and you need to have a diversity in this community. And not only you need to have a diversity, you need to make the community welcoming to those voices which often are not heard. Today, if you would look at Twitter, which is this great battlefield of the scientists, you will increasingly hear women scientists talking about how their voices are not heard in a room filled with old white men. And they're talking about the great contributions they do and how you're going to make this community of scientists more welcoming and be more productive by listening to the voices. So I have to say, if science is to really improve, it also needs love. In a different way than we would talk about it. But it needs love to build that community so that everyone is welcome and voices can be heard. You need faith, you need hope, you need love. And if I've convinced you of that, then my job is done. No, not really. I think there's a great gem in the story of the Magi, which is often not really seen. And we have talked about it a bit, but we've not really come to the story. And I think the great gem of the story is really what they found at the very end. I mean, I would really like to have been there just as the Magi come in and see the child and like, a child? And a child like this? In this state? And supposed to be the king of Israel? It was the most unexpected thing they were supposed to find. I mean, if they had come from their own cultures, they would have expected to find the king of Israel in great splendor. I like to draw an image on this and say, you know, this happens all the time in sciences. I go into my research and I say, hey, I want to find this and this is what I expect to find. And then when you go and you search and the universe always surprises you. And it gives you such nasty surprises because it doesn't behave as you would like it to expect. I learned this quite painfully. 1/3 of my PhD thesis was wrong because I expected the universe to behave in a certain way and it did not. And I only discovered it after I graduated and came here to the University of Michigan. I realized 1/3 of my thesis was wrong because I expected my model to work and I never tested it. And it did not work for the universe. One of the great things about science is that the more you try and search, the more the universe surprises you, just as God surprises us all the time. That's for me the great gem of that story. So in a sense, I'm trying to paint for you a picture of the sciences, how it has, how they evolved through a very different story of the three Magi. You must tell me at the end of it whether it worked or did not. But let me show you a flavor of what the sciences are talking about and what astronomy is talking about. So now I want to go back to the three basic, very briefly now I'm going to do towards the last end of this talk is very briefly the three basic questions which people talk about in astronomy. And what I want to do in these three basic questions is to summarize the full of astronomical research in these three basic questions. I'm not going to do any technical details, but just to give you a purview of what are they studying, these astronomers? Why are we giving them money through the NSF and through the government funding? What are they doing? And I would like to show you that these three basic questions are the basic questions all of us have. The three basic questions are very simple. Where do we come from? Where are we going? And are we alone in the universe? Okay. The first question is, where do we come from? Okay. So if you look up in the night sky, okay, you will realize that there are millions and millions of stars. You kind of have seen it in some way, but you never really counted them. Take it as a basic fact, there are millions and millions of stars. And in our galaxy, we have like a large number of stars, 10 billion stars in our galaxy, given more or less. Okay? The nearest star to us is about, roughly, like, it takes about light 4.5 years to reach it. 4.5 years it takes to reach it. Take that as 1 unit, which we will call as a parsec. Yeah? The distance from us, from one end of the galaxy to the other end of the galaxy is about 100,000 times that distance. There are a million stars. It's a huge, vast space. Light will take us 100,000 years to reach us from this end to that end. To give you a sort of perspective, when you think of it, think of us as, this is an example of our galaxy. This is not our galaxy because nobody can go out and look inside and say, this is a picture of our galaxy. This is an example of our galaxy. Our sun is somewhere around here. It's around 8,000 times the closest distance from the center of our galaxy. This is a humongous. We can never reach the end of our galaxy. This is how big space is. This is not how big space is. Because there are millions and millions of galaxies like this one. And all of them are islands. And they are so far apart that if you would consider it, if you consider as one unit as a kiloparsec, one unit as a kiloparsec, that would be 100,000 times more distance. It's so far. They're like islands, the vast sea and islands. If any of you have been to the Tucson area in Arizona, if any of you are snowbirds and go down there, you will notice that it's a desert, and suddenly these mountains arise from the middle of nowhere. And pretty much the universe is like that. Galaxies, and then vast, vast, empty space. So much of our research really today is about where do we come from? What is the origin of our universe? Now, this slide is summarizing 80 years of research. So it will probably raise more questions than answer them. So what I'd like to point out to you is that somewhere around here, there was a Big Bang. And we are somewhere around here. And that's 13.6 or 7 billion years ago. 13.7 billion. We know this to such an accuracy. In fact, the original, if any of you are engineers and know what boundary conditions are, the original boundary condition of the universe, we know with such great accuracy. How do we know all this? People have been asking good, important questions these last 60 years. They actually know the first radiation which came out from the Big Bang called the cosmic microwave background. And we can actually observe this radiation. We can actually count galaxies. We see millions and millions of them. This is the product of scientific research. But basically, all of this asks the simple question. Where do we come from? Where do we come from? What's the origin of the universe? And I explained to you this basic idea of the expansion of the universe from a single point comes from Father George Lemaitre and later on Edwin Hubble. Do we know that there was a single point there? No, we do not know that. But what we know that it pretty much came from a very small space. That's more we know modern research. But more so, we like to understand also how do galaxies grow. And we realize that galaxies grow through merging. Now, these are galaxies and they constantly merge. And this is the type of research I do. I try and understand how galaxies merge all the time. How do they grow over time? So I do computer simulations and try and understand, hey, what was the history of our Milky Way? Which galaxies, because of gravity, they're all falling in together because of gravity, which galaxy did our Milky Way eat for dinner along its history? This is the kind of questions I ask. So I look at a galaxy and I try to say, hey, that's a galaxy. How did it grow to that size? What did it eat along the way? What did, eat means gravity, right? I mean, this merging, eating is a synonym. You get hungry, or it's quite late now. This is the kind of question. In fact, my latest research is about our neighboring galaxy, which is called as Andromeda. You may have heard the term from the Greek gods, Andromeda galaxy. I discovered, with my colleague at the University of Michigan, we recently discovered that Andromeda, in the course of its history, ate up, so this is Andromeda, it's called M31, and in the course of its history, it ate up another very large galaxy. That was 2 billion years ago. And that galaxy was as large as our own Milky Way. 2 billion years, we know this for the first time in I don't know how many years. And that galaxy was as big as the Milky Way. So this is the galaxy which came in, this is Andromeda, it fuses, and then you find off a bit. How do I actually do all this? By magic? No. The best way to think of it is, I try and look at breadcrumbs. What do I mean by this? All of you have had children. You know that if you leave your child there to eat, and you come back after 10 minutes, there'll be this huge sea of breadcrumbs, crumbs all around the place. And if you walk in and you look at the crumbs, and you pretty much know your child ate broccoli and she ate the bread, but she did not eat the rice and she did not eat this. You pretty much can look at the breadcrumbs around the galaxy and discover what the galaxy is. That's what I do for a living. I look at galaxies, I look at its breadcrumbs all around, and I piece together like a detective, an archaeologist, what that galaxy ate over its course of its lifetime. This is my research in one sentence. So, just to give that a perspective, we had a few years ago there was what we used to call the family portrait of our local part of the universe. And that family portrait had Andromeda, it had the Milky Way, and it had these two galaxies, which are very close to us. They are very small in size. Suddenly we realized, oh hell, there was something big. And our nearest neighbor, Andromeda, ate it for dinner. Okay, that's my kind of the research I kind of do. Also asking the question, where do we come from? All under the space it will come from. We constantly ask this about stars. We look at galaxies. We see where the stars are born. We see them born in dust clouds. You get a small little thing over here is a dust cloud. Dust clouds are filled with gas. That's where new stars are born. You zoom in. This is the Horseshoe Nebula. You zoom in. It's filled with new stars are continuously born. And then each of them will one day burst in a supernova and create the elements. And what do you realize is this process goes on and on in the history of the universe. And our star, that is the sun, is a third generation of this process that happens. And basically all of us here have various elements which are in our bodies. You have a bit of water, carbon, hydrogen, oxygen, but you also have a whole bunch of other elements, minerals like magnesium. Doctors over here, please don't go. Magnesium, sodium, all of that is created in these processes. So pretty much we are all stardust. We are made from the dust which comes from stars. And the third area, this again asks the question, where does our sun come from? And the third area which is very active in research today is trying to ask the question, when stars are being born, this is the gas cloud which forms a star, there is like a small swirling gas which is left around, and they form the planets. And the question comes, how do planets form? And this is another great area of research which is being done today. Again, how do planets form? We'll come back to planets because that will ask the last question about are we alone in the universe. The second group of questions which is very important today is, where are we going? What is the fate? What is our fate? Our fate is quite tragic, to be honest. Within a few years, 4 billion years, I'm sure some of you will live till then, our star will die pretty much and will not be able to support life. This is something which some of my colleagues study all the time. I study collision, so I like to study when is the next big thing going to come and hit us. So I'm studying how the next big thing, which is the Large Magellanic Cloud, the small satellite of us, will hit us within 2 to 3 billion years. And then further down the line, my colleagues and I have already predicted that Andromeda, our neighboring galaxy, will eventually eat us. And that will be 7 and 8 billion years ago. That's too much in the future by the time our star is already dead. But this is the question, where are we going? Most of people are trying to understand about the universe. What will happen to our universe? And they're trying to ask the question, will the universe expand continuously? Or will it at some point, like you throw a ball up, it goes up, goes up, goes up, and eventually falls down? Will it contract to the very end? So today we have become increasingly aware, and through a Nobel Prize, we have realized that the universe will infinitely expand. It will never contract. In fact, the universe is not only expanding, it's accelerating. It's going at a faster and faster pace. So eventually, the universe will just like fizzle out. It will become so diffuse. And the reason why this happens is because our universe is filled with something which we don't understand. The 74% of it is filled with something we don't understand. And because we don't understand it, we call it dark. And we call it a dark energy. You know how we don't understand the church's history? We call it the Dark Ages. It was not dark. They were pretty bright people then. But because we don't know of it, we call it the Dark Ages. Similarly, these are the big questions. Where are we going? What is this dark energy all about? Why is this happening to our universe? So a lot of our taxpayers' money is going in answering these questions. And finally, this will be the expansion of the universe, until finally everything fizzles out. And finally the question is, are we alone in the universe? Now over the last few years, this has been the biggest research topic in astronomy. It's become like the hottest research topic in astronomy. We always knew about planets in our solar system, right? We knew about them. But the question was, are there planets around other stars? And because they are so small, the planets, in comparison to the star, we could never really detect them. Now, thanks to an advancement in technology, for the first time, we can actually detect planets around other stars. But the first planets which we actually discovered were the big ones, because the bigger it is, the more you can see it. So we discovered things like Jupiter. Jupiter is this big, gassy planet which orbits the sun. We found Jupiters around other planets. And now suddenly we begin to find Earth-like objects around the other planets. So now we have had a whole bunch of other planets. You can see them, Earth in perspective, and you will notice immediately that most of them are bigger than the Earth, because you want a bigger one to see it. If it was a smaller one, you can't see it. But this is slowly changing. Okay? Recently this came in the news. I don't know if you ever remember this. There was a discovery of a system which is named in a very Catholic name called the TRAPPIST. Okay? It was named after the Belgian beer the scientists were drinking. But let's not talk about that. And they discovered that there were 9 planets. And some of them in comparison to the size of our Earth. We found an Earth-like planet. But really what we really want to find is a planet which can support life. So it has to be at a safe distance from the sun. It must have an atmosphere, a protective atmosphere. It must be able to protect the organisms against the harmful cosmic rays. And it must have water, liquid water. And this is the big quest in astronomy, to find the first planet where there can be a probability of some life going on there. Today, we have discovered more than 3,000 planets. To just give you a sense of it, this is a plot, the only plot I'm going to show you. This is the period around the star, and this is the size with respect to the Earth. 1 being Earth, 4 being Neptune, and 10 being Jupiter. And you can see this great abundance of planets we have found. And some of them quite comparable to our Earth. The question now comes is, can we detect something in their atmospheres? Can we detect that they have water? Can we detect that they have life? All of this is from the simple question, are we alone in the universe? So I have to point out that all of astronomy is this three basic questions. They are transcendental questions. They are existential questions at the heart of each of us. Where do we come from? Where are we going? And are we alone in the universe? I'd like to end on a rather humorous note. And the question is, I'm also making an advertisement for a book by my superiors, Guy Consolmagno, is, would you baptize an extraterrestrial? And it's a lovely book. It's all the questions we get in our Vatican observatory mailbox. And we get weird questions all the time. And so he summarized all the questions with the answers. And Brother Guy Consolmagno's best answer to this is, only if she asks for it. With this, thank you for your patience. I'm sorry for the word.